what happened was they basically moved it over to my office.
We're talking about Bill Hill's vent that's driving us all nuts.
Yeah. So yeah, Beat next door got the facilities guys to fix the draft in his office, and they basically transferred it to mine. So that's okay. I don't mind.
Yeah.
Will you be able
This is how we torture employees. We put vents right over their heads.
Will you be able to edit? Because I basically...
I don't do editing. We're already filming. You haven't even noticed that, have you?
This is flying without a parachute.
Oh, no.
See, people on Channel 9, they think I actually plan this stuff, but no, I just walk in and have conversations with the
Because I
type
kind of
team.
wanted to start with Monty Python's The Life of Brian.
Yep.
Right, you remember when the Jewish terrorists, you know, John Cleese and those guys are sat in the room plotting against the Romans, and they say, "What have the Romans ever done for us?" Right?
Yep.
And then, like, well, there's education. Well, apart from education, what have the Romans ever done for us? Well, there was water. Well, apart from water and education, you get the picture, right?
Yep.
Well, in terms of type, you know, it keeps coming back to the Romans. What have the Romans ever done for us, right? Well, all the capital letters that we have in the Latin-based languages are Roman. We owe the kind of widespread nature of our alphabet and our writing systems to the Roman Empire, basically.
And this was how many years ago?
Well, you see the thing. Well, about 2,500 or thereabouts was kind of when the Roman Empire basically got started. I'm in the middle of actually reading Gibbon's Decline and Fall of the Roman Empire just now. It's about 9,000 pages, and I'm reading it on this guy, right?
Wow.
Using the Microsoft ebook reader. This is a 200 DPI Dell Axiom Pocket PC.
Now, is that the same one you showed us last time we were
Yeah, I
walking
think
around
probably
campus
is.
with you?
So anyway,
Did you hear we're scanning all the British Library's books, by the way? So you'll have a few, more than 100,000 books to read on that.
Yeah,
thing.
I hope to scan them and put them in a text, or we don't scan them.
Do you think you can read that? That many books?
Take more than a week, right?
Yeah.
But anyway, I mean, the kind of classic example of type from the Roman Empire is Trajan's column, right? Which the Emperor Trajan erected to celebrate some triumphant massacre or other, you know, a kind of expansion of the Roman Empire in about the year 114 AD. So, and this is kind of where we are in the type world. You know, we don't think, when you're designing type, you don't just think of the moment or there. You have this history that sits behind you of 5,500 years. You know, one of the first typefaces, well, it wasn't a typeface, you know, but the first writing systems were based on the marks you could make in a piece of clay with a split reed, right? And cuneiform writing kind of grew out of that. And you know, for 550 years, we've been designing type for print based off the Gutenberg technology. Now, what's going on just now is something equally historic. You know, it's as historic as Trajan's column, it's as historic as the Roman Empire. It's this shift from reading in print to reading on the screen. We were talking about this morning, Greg, and I said to Greg, you know, how many people do you think print out blogs to read them? None. Exactly. Yeah. So you have a new form of journalism that's kind of democratizing journalism and democratizing writing, and nobody prints these things out. So the form of cuneiform lettering was based off the medium. You know,
what is cuneiform, by the way?
That was the kind of early Sumerian Mesopotamian writing system that was created by pressing reeds into clay, right? So now the form of type that we all use today was kind of based off the world of print, right? And we've had 550 years of development of that. Now we're moving on to a new medium, and the form of print kind of dictated the form of type. You know, the medium dictates the technology, because, for example, you couldn't have stems of letters that were too thin in printed type, because mechanically, you might get bits that snapped off during the printing process because of the stresses and strains that go on type. So there were things you could not do in print, and also type design. You wanted to design the counters of letters so it didn't fill with ink, for example, during the printing process. So the medium itself, it's the medium is the message. The what's his face, McLuhan, yeah. So the form was determined by the production process. Well, we've kind of moved away from that, except that we haven't yet got the resolution that we want on screens. We have on some screens, like that 200 dpi Pocket PC and my big 200 dpi screen, which is out on loan at the moment to the guys who
Somebody stole it, huh?
Somebody borrowed it because they're doing high resolution work for Windows Vista, and hey, that's the #1 priority in the company. Yeah. So I figured that I could lend my display to those guys for a few weeks while they're testing. But anyway, we don't have high resolution screens yet, so we're working in low res, and so as I said, there's this big historical change that's happening where stuff moves to the screen, and we started all this, as you know from past conversations, kind of with Verdana in Georgia about 10 years ago. So this was the first time that instead of using typefaces that had always been designed for print, we looked at the screen and said, what are the capabilities of the screen? How can we design type to optimize for that? That was Verdana in Georgia, and those were the best that you could do really with low resolution technology in the black and white world. And then along the way we invented the Cleartype technology, which opened up a whole bunch of other stuff. So I guess 2 or 3 years ago, about that long, we started to think, we have this new medium now, we have this new Cleartype stuff, and we know a lot about how to hint type for that world and so on, but using kind of our regular faces. So what if we design some faces specifically understanding the Cleartype technology and to take them to get the maximum benefit out of it? So it was a little bit of a hard sell in the beginning. At that stage we were actually in Bill's organisation. I reported to Dick Brass, who reported to Bill for a while. So we put forward a budget proposal. We said we'd like to design some new typefaces specifically for reading on the screen with Cleartype, optimise them for Cleartype. Oh, and by the way, we'd also like to try to address the challenge of East Asian languages like Japanese, because if you think it's tough doing Latin on the screen, try Japanese. You get characters like the kanji character Utsu has 8 horizontal strokes, which means you can't portray those in less than 17 pixels. Well, 17 pixels is a lot. It's very big type at standard resolution of about 100 dpi. So we put forward a proposal to go and create 6 new Latin typefaces and a new Japanese typeface. And in the normal budgeting process of Microsoft, this kind of bubbles up through the channels. It got to Bill. Bill said, I don't think we should spend this at this time. So, faced with that, of course, Microsoft is much more democratic than people think. Bill expects you to say, no, you're wrong, if you think he's wrong. So we did. We said, no, we should do these. We know we can make a big leap forward. And he said no again. So we said, no, we're not taking that for an answer. And we pushed back a 3rd time, and he said, okay, we'll have to have a review. So we had a review with Bill, and we showed him the plans, and eventually he said, yeah, okay, you can do it. So what we did, and Geraldine drove a lot of this project.
Why, to get into Bill's mind, why was he pushing back so hard on you?
Well, everybody pushes back on money. Yeah. People think Microsoft's kind of awash in money, but we're very cost conscious, right through all the groups. Budgeting's a tough process, and things get cut, things get pushed back on, and you have to fight for something that you want to spend money on. Especially, this was a significant amount of money. Yeah. It was in the millions.
Bill also was very interested in
Now, who are you?
I'm Greg Hitchcock.
Okay.
In doing fonts that got used. We had Times New Roman, Arial, Courier out there. We had Verdana in Georgia, Palatino, Linotype. So, if we're going to bring some new fonts out there, how are we going to assure that they get used? And we really wanted to emphasize that we're going to be able to do a lot more with readability, to bring a lot more to the screen with these new faces. So that was one of the key messages we sent to Bill when we met with him.
Yeah. When we met before, you mentioned when you came to Microsoft, the average length of text that somebody would read was a few paragraphs.
Well,
right?
it was a guess.
It
didn't really have any hard data, but it seemed to me that at that time, which was about 11 years ago, people would read a 3-paragraph email on the screen, but if you sent them any more than one screen full of text, they printed it out because it was awful to read on the screen. So the game was to try and push that up to the point where people could read as much as they wanted to on a screen without any of the kind of eye strain effects and just comfortably read as long as they wanted on the screen. And that's really what we've been doing since then. And with each of the things that we've done, we've kind of pushed that limit further and further. So we decided to create 6 new typefaces, and one of the typefaces we decided to create, people kind of have for years, because it comes from the print world, because type comes from the print world, people have been ignoring the needs of developers, for example. Right? These are people who spend a lot of time at the screen. They may not think they're reading, but they're doing a lot of reading, and they were stuck, most of them, using Courier. Now Courier was because when you're coding, you really want a monospaced typeface.
So everything lines up.
So everything lines up, and you can easily spot your variables and all that stuff. The syntax is much easier to get in a monospaced typeface. So people were stuck with Courier. Now you might not know the history of Courier. Courier is actually a pretty light typeface on the screen. And one of the reasons for that was when Monotype created, I think it was Monotype who created the original outlines, they took them from the golf ball on an IBM Selectric typewriter, right? Well, the weight of the characters on the golf ball is actually much thinner because it's going to impact through a ribbon. So when it impacts through a ribbon, you get the actual Courier, but if you take it from the golf ball, you get something that's very much thinner and sharp-edged. And it caused all kinds of problems where, at certain sizes, without hinting, some of the stems in Courier would disappear altogether, because they're below 1 pixel in size. So anyway, this is a kind of a historical thing. So people have been using Courier to code for years, and we thought, well, there's a bunch of guys that deserve a break. Somebody should actually look at, because developers are a very important constituent for us. If people aren't developing software to run on Windows, Windows is not successful. That's part of its strength, is the installed base of software that comes from the number of developers who work on it. So somebody should give these guys a break. One of the typefaces that we'll do a new monospace typeface designed for developers, and we'll make that as readable on screen as possible.
That's named Consolus?
That's Consolus, yes.
Consolus.
Yeah. So we're not consoling people, we're getting them to use it on their consoles. so Consolus, yes. And of course all these typefaces, we had to give them a letter C to start because they're all Cleartype typefaces. So Calibri, Consolus, etc., right? So we then went out to designers, all the type designers we knew. We wanted to work with the best, which we've always been able to do in the past. And so the whole team has kind of always been driven by excellence. How good can we make this stuff? So we wanted the best designers. So we kind of ran a competition. Went out, we gave a design brief out to designers and said, if you design typefaces, we'll judge them in a competition. Here are the kind of categories we're looking for, and we'll pick the best.
So who won?
Um,
And who are you?
my name's Geraldine Wade, and I'm a program manager at Microsoft,
Yeah.
working in the Advanced Reading Technologies team. And yes, we set out to actually do a competition to gather kind of as many as we could submissions, and we had about 26 submissions. And out of the 26, we chose 6 of them. We did a detailed kind of study of the submissions. We pre-hinted them to see if they'd render well on screen. And those ones that actually came out the best were Lucas de Groot. He actually won twice with what turned out to be Consolas and Calibri. And John Hudson with Constantia. Gary Munch with Kandara, and Yellow Bosma with Cambria. And yeah,
Now, to get to this point, how many hours does it take to make a font like that? To win a contest like this? Do they work for 6 months on a font?
No, we asked for original designs, and some of them had some things lying around already,
Yeah.
and some of them decided, well, they'd have a go. And so when they submitted, we were looking for specific things that would render well on screen, such as the outline weight and the way it would represent on screen with Cleartype. And because we can hint here, we can do a quick kind of scan of how they're going to represent. Well, we could see right at the beginning that some of them were very good. They were very classic looking, but they didn't have that modern, clean feel that we were looking for. And some of them, what we look for also is the fact that the weights should render well. Regular, bold, italic, and bold italic. They should all work well as a family. And you can have some faces that have been submitted that are really great as a Roman face, but the italics are not quite, they don't quite gel together as well.
Have you guys read Malcolm Gladwell's book, Blink?
Yes.
Yeah. Was it a Blink experience? Did you just see that typeface and within a microsecond did you know that was the one?
Actually, we had some heated debates. Simon Daniels, also on the Microsoft Typography team, was with us, and we had some toing and froing on which ones we actually preferred. Because some render really well, but it was the overall impression of these faces that we were looking for.
What do you call 2 typographers in a room?
What?
An argument, right? so when Geraldine talks about heated debate, that's exactly what happens. Because we're in a strange area here where art and science meet. That's what Gutenberg called type, a mixture of art and science. And so you're into a world of opinion and design and people's ideas of aesthetic beauty and so on. So there are always arguments about stuff like this.
Oh yeah.
But eventually,
I've started some of them on my blog, by the way.
Yeah, absolutely. And so have we on our blog.
Who has the better fonts, Windows or Mac?
Windows.
That's good for. Well, we all say Windows.
There's no contest. No, there's no. There actually is no contest on that one.
Yeah.
Now, if you want me to get controversial, here it is. Even before I was working for Microsoft, when I was working for Aldous back in Europe in 1991, when I installed Windows 3.1 and saw the core fonts, I looked at them then, called my boss over, Derek Gray, who later became a vice president of Adobe. I called him over and said, look, these guys have way leapfrogged past the Macintosh in terms of readability on the screen. This was Times New Roman, Arial and Courier, the Windows 3.1 core fonts. These are the guys who did it, but I noticed it even then, and
So when you say these guys, you're talking.
I'm talking about Greg and Geraldine.
So you guys have been working at Microsoft for that long?
Actually, I was originally working at Monotype Typography, and Microsoft came along, and actually I started working with Greg right back then in 1990. Yes. So.
Yeah. So this team, a lot of this team has been together a long time. I mean, Kevin's a new boy. You've been here how long?
3 years.
3 years. I'm one of the next newest, and I've been here 11. Right? It's a team of people who've been together a long time. And Geraldine, she's being modest, referring to herself as a program manager. I mean, her background is she has 2 art degrees, including a master's. And
She's blushing.
and she also has an honorary BSc in computer science. And you know, when I ever refer to Geraldine or Mike Duggan, who's another member of the team, who again came to us from Monotype, I always refer to them as typographers, and probably the two typographers who know more about designing type for the screen than anybody else in the world.
The argument.
Now Geraldine would be really blushing at this point, but I don't care. You know.
The argument I get back is the Mac has fonts that look more faithful to the print versions of the fonts.
Precisely, and that's why they're not as good for reading on the screen. You know, and the screen readability stuff is the really hard stuff. Hey, it's easy to do. It's relatively easy to design fonts for print. You just create a set of high resolution outlines, and then when they're going out at 300 dpi, even at 300 dpi, you need some hinting. But when you get to 600 and 1400 and 2500 dpi for high resolution, but that stuff's easy. You can go and you can create whatever you want, and it's going to look good because you've got the resolution. The tough stuff, the really tough stuff, is doing it at low resolution.
You're nodding your head.
Yeah, Greg's nodding his head.
The
He's
technique that
blood.
Mac uses is they blur the text. That's how they make it look good on this. Well, good is how it faithfully can represent the printed paper is by blurring it on the screen. The techniques we've chosen try to enhance contrast as much as possible, and sometimes we have to do things that take it off the linear path from the print, but it is a faithful representation on the screen and is much easier to read.
You see, this is back to back to this thing about the medium again. You know, if you're designing type to be printed, and in the early days of desktop publishing, for example, you know, final output was always print. So the type that you had on the screen only really needed to be to give you an idea of what it was going to look like. WYSIWYG was what it was all about.
Yep.
You should get pretty close to what
Well, I
it was
used
going to look like.
PageMaker back in the 1.5 days.
Yeah, well, I was even earlier. I did my first PageMaker document in PageMaker 0.89.
Wow.
I was on the beta program, and that would be about September 1984.
Yeah.
Right, that was really pretty early. But the whole thing in those days was about WYSIWYG.
Yeah.
The type on the screen was not designed to be read. It was designed to give a
It
representation.
was very blocky back then. Yeah.
Yeah, and
I've got a quick kind of, just this part here is about screen hinting for black and white,
Okay.
and the kind of problems that you'd come up with. So this is the actual outline. Somebody has actually sat there and
Let me mess
actually,
with my tripod a little bit. Hold on a second. There we go. So,
someone's actually, you know, obviously the designer's gone in and drawn this outline. This is Herman Zapp's Palatino linotype.
Yeah.
And this is a naive rasterization of this B character, and as you can see, it actually doesn't represent very well on the screen
Yeah.
in black and white. And this is what you would do if you were hinting this character to accentuate the serif and make sure that it represents well as a very nice clean B down at 12 point.
right.
And these are the kind of issues that you get if you have this naive rasterization before hinting, where you have the outline and what happens to the pixels underneath.
Yep. We used to see this on early computers.
Exactly. So with hinting, you can actually you can control both the horizontal and the vertical direction. And so basically you can have a very clean but very blocky bitmapped kind of visualization of a character form. And this actually is not a true representation of the original designer's intent, because you've missed out on all the beautiful subtleties of the design. And with Cleartype now, and with these new designs, you can actually get closer to the original designer's intent.
Now, I was a beta.
so hinting
Okay.
of that sort is a mixture of the original outline design and then a whole lot of programming that goes on. I mean, the core fonts that shipped with Windows 3.1, Times New Roman, Arial and Courier, each had about 25,000 lines of code in them.
That's how I ended up with my honorary Bachelor of Science degree, because we had to handwrite that code. Yeah.
Yeah.
And
so back in those days, it was kind of a hand process.
Yeah.
And I mean, for Times New Roman, Arial and Courier, it was really, you have to do some pretty brute force things down at low resolution. I mean, there's lines of code in there which turn on an individual pixel in a particular character at 10 point.
Yeah.
Right? There's a line of code that actually represents it. It's called a delta hint, right? Where there's a kind of a specific instruction to one pixel you will turn on, you know, and that's pretty brute force. So there was a huge team that had to hand code all that stuff
basically
for the Windows Core fonts. Now, what's happened over the years is we've gotten better at this. We've got more systematic about this. We've got some automated tools that help.
Also, I'd like to just point out at this moment in time is you have the original outline, you have a black and white rendering underneath naive rasterization, and this is our grayscale and what it would look like also if it was not hinted. And then when we actually came to actually hint the font, we might make a very nice K in this particular case at 10 point. But if you can see here, we've actually manipulated the outline. We've had to shift the outline in order to turn off the pixel. Well, when we had grayscale turned on down at these small sizes, we had this kind of uneven effect happening, this kind of difference of almost like a foreground background thing happening at the same time.
Which makes the font look blurry or look like it has an
flickers.
artifact or something.
Yeah, so that wasn't really anything that we wanted to really go for. It looks great at the highest sizes, but at the low reading sizes, and that's where we're really interested in making the best possible fonts work for the screen.
Yeah.
So then we had Cleartype, and that was another. You know, as I mentioned, we got better at hinting over the years. So when we did the hinting for Verdana and Georgia, for example, that was kind of easier, especially since we designed these typefaces up front for the screen. So we avoided some of the worst problems that you hit. Sometimes when you're hinting down at these low sizes. And we started off with Verdana with 10 and 12 point bitmaps, and then designed the outlines around that.
I was a beta tester on Adobe's multiple master fonts. Why did those never catch on?
Well,
and maybe explain what they were trying to do. This is back in the early 90s, where they had two weights, like you could have a bold and a non-bold, and you could have
basically what they were trying to do was allow complete flexibility in weight, so you could go all the way from very light to very bold, and you could go all the way from perhaps a grotesque type face, which is somewhat elongated, to a condensed face. The problem is that stuff, as we learned the painful way by trying to hint, does not work on the screen particularly. It works in the print world again, where you have the resolution, but in the screen you have these very finite jumps, and a jump of 1 pixel or 1 point in size can take your stems, for example, some of the stems from 1 to 2 pixels. And what happens often is you get kind of rounding errors. So you get, for example, letter N unhinted has a 2 pixel stem and a 1 pixel stem. We all saw this back in the early days of screen fonts, and that was why in the early days they actually delivered outline fonts for print and bitmap fonts for the screen.
Do you think that now that screens are going up in resolution, are we going to see another attempt at that kind of idea?
Again, we're going to see some of it, but still, even at 200 dpi screens, the jumps are still pretty finite when it comes to. I mean, we're dealing with very small elements of characters here, stroke weight and things like serifs and so on. It kind of might really come into its own if we had, say, 300 dpi screens. But even then, there are big problems. I mean, to go from, for the last 5 or 6 years, resolution of screens has been about 100 dpi or thereabouts.
Yeah.
But to go from 100 dpi displays to 200 dpi displays means 4 times the number of pixels that you have to compute, because it's n squared, right? You've got to go to 300 dpi screens is 9 times as many pixels. That's a lot of graphical processing, and that's one of the kind of bottlenecks. Is that you need a really powerful graphics card, which eventually you've got to cryogenically cool the chip on, because it's it's dealing with so much computation.
You have to have a nuclear reactor on your motherboard to power the thing. Right?
Well, that's right. It's not terribly practical for a laptop, for example, to go to a 200 dpi or a 300 dpi display when your battery life is about 10 seconds. You know, you don't really want that in a laptop. So the increase in resolution of the screens is happening very slowly because of these technological issues, and there are some other issues in the background too. People have to design software that's resolution independent, because when you see what happens if you don't do that, you get websites that look like postage stamps on your screen and stuff like that at 200 and 300 dpi.
Not to mention the baby boomers like me are getting older, and it's getting harder and harder to see the small fonts.
Right. Old guy, right?
Yeah.
Yeah, I mean, I now have to use glasses to read on the screen, or to read anywhere actually. I mean, I can't read a booklet like that now without my glasses.
Yeah.
It's hey, one day they'll shoot me. I'll be old and decrepit.
What else? You had something else you were.
Well, I was just going to briefly talk about when we actually had the designers. We decided, okay, this is the 6 that are going to go forward and make these fonts. We had them come out here. We had a few days where we went over Cleartype technology and the rendering and what it would look like on screen, and what the kind of problems or advantages that you get with Cleartype when you're actually thinking about designing specifically for this kind of rendering. And so we would sit down, and this is a shot from Jeremy Tankard's notebook in our discussions, and this particular A here, we were discussing the weight of the outline, the joins, what works, what doesn't work, and this is the eventual outline now under Visual Type tool. You can see the weight run here, size run here, and this is Lucas de Groot's Calibri. He actually submitted 2 designs. One was a sans serif, exactly like this, but with straight edges, and this one with rounded edges. And we liked the one with the rounded edges because it gave such a beautiful, human, lovely feel to the page. And he was really surprised when he found out that we'd chosen it, because he didn't think that these rounded edges would work well, render well on screen. And we tested it out.
Before Cleartype, they wouldn't render well on the screen. That was the point.
Yeah.
Cleartype allowed us to do something we couldn't have done any other way.
At the smallest sizes in particular. I mean, you can get beautiful anti-aliasing at the larger sizes, but when you get down to the reading sizes, it really comes into its own. And so this is the same A, rendered in black and white. And as you can see, it's very jagged edges. And this is the actual A with Cleartype rendered, and if you look up here, you can actually see that you can differentiate the soft edges, the soft curve.
So the top one's not Cleartype, the bottom one's Cleartype.
The top one is black and white, the bottom is Cleartype.
Wow, what a difference. And what's interesting is here you can see how you're using color and using the color perception that you talked about in earlier videos. It's not a grayscale, it's actually using color and using the way your mind perceives color to soften the edges.
The way your eye and your mind perceive colour. It's kind of it's the whole visual system.
Yeah, this is if you like, this is a higher level representation of what's going on in the subpixel domain. This is a visual that just shows the kind of things we were looking at when we were designing these typefaces. The designers we'd be looking at the characteristics that would work really well. And in the old days, the beautiful faces like Garamond and Rimbaud, some of the hot metal typefaces, they are absolutely gorgeous, but we don't have the screen resolution that allows us to be able to see that well down at the small reading sizes. And so we were looking at, if you look, the difference between these two, obviously they're different fonts, but the actual things we were looking for were heavier serifs, very strong joins, heavier hairlines, heavier diagonals, and these characteristics actually help render well on screen with Cleartype. And also a horizontal kind of way of designing G's, A's, the shallow joins. they also represent really well on screen. They give you a very strong G down at the small sizes, whereas this one comes out a little weaker.
And that actually shows some of the some of the ways that Cleartype renders. It renders lines this way less well than lines you know.
In a sort of soft diagonal,
Yeah.
especially. Yeah.
Vertical lines are rendered sharper than horizontal lines, right?
Yes.
So you actually design the font to
Yeah.
take advantage of that.
Yeah. So
You're
Exactly.
so you might think, okay, well that's going to make some kind of homogeneous looking typefaces all over the country. They're all going to look the same, but these 6 typefaces show that you can be very unique in your designs and yet still have the similar kind of characteristics of a strong join, horizontality in the G, and the strong joins of the A. And this is the other 3. We have the same things going on there. And these triangular serifs work really well. They look like a letterpress.
Yeah.
So
On the tablet PC, by the way, does that change because you're reading type on
Depends. If you're using a tablet PC in portrait mode, generally the striping runs the other way. We found that the algorithms that we had developed, there's a lot more going on in Cleartype than just the use of the RGB subpixels. There's a lot of sophisticated signal processing going on to kind of take advantage or to mute the colour fringing that would happen, and the way you do that is by almost dissipating some of the energy to adjacent pixels and so on. It's pretty complex. We have a lot of patents filed on the technology behind it, and the guys from Microsoft Research, guys like John Platt, Turner Whitted, and those guys, they helped a lot with some of the math involved in the signal processing. So there's a pretty sophisticated colour filtering thing going on, as well as just using the RGB subpixels.
Yeah.
So we went out, we had a competition, we picked the best designs that we could see. Then we worked to get the outlines, the character sets filled out. Excuse me. Then we did the hinting to make sure they looked as good as possible on screen. And in the process of that, of course, we then start circling back to Bill's question, which is, who's going to use them, right? So it's about customer, getting the customer and getting the maximum reach. Well, Microsoft was currently working on the next version of Windows, which at that time was codenamed Longhorn, now Windows Vista. We went to the Windows Vista team. We're now part of Windows. We're now part of Windows Client.
And we're in Building 10.
Yeah. Well, see, that's a whole other story. Bill had been telling us for a long time, I want this stuff. I don't want this stuff in I mean, applications like Microsoft Reader and so on were all very well. I really want this stuff in mainstream. I want it in Windows. I want it in Office. Because I mean, I've gradually come to the realization.
You move my tripod over here. Sorry. Okay. Yep.
Without being too pompous, I came to Microsoft to change the world. I want to move the world from reading on paper to reading on a screen. You want to change the world, there's 2 things you can change. Windows and Office, right? Because you change Windows and Office, you change the world. There's 500 million people worldwide using Windows. You change Windows, and eventually as they all upgrade, you find 500 million people using technology that you develop. There's no greater way to make an impact in the world than to do that.
Yeah.
So we started out looking, we talked to the Windows Vista team, we also talked to Office, and they both were delighted to see the work, they loved the designs, and so the next versions of Windows and Office will both ship with these new Cleartype fonts. They'll ship first in Windows Vista. I think it ships first in Office. Right. Office 12 should ship just before Vista.
Now, are the fonts going to look as good on XP, for instance, as they will on Windows Vista? In other words, is the Cleartype technology totally the same?
Well, there's a slight difference. Windows Vista, the kind of a base product, will have the same kind of technology as Windows XP. However, we're part of Windows Client Platform and Documents team, which is really the Avalon team.
Yep.
Right, so all that Avalon technology, which is now will ship with Vista as the Windows presentation framework, that has, if you like, the latest, greatest version of Cleartype in it. In the beginning, when we developed Cleartype, we used the additional resolution to improve the character shape. But we realised, we're on about version 7 of Cleartype now. I mean, as we've gone along, we've improved it all the time. But we realised that if we applied the same resolution also to the spacing of the characters, because one of the things we found from Verdana, for example, was that the spacing between the characters was as important as the shapes of the characters themselves in good readability. So we realised we could use the additional resolution for character placement and spacing as well as character shape. So we developed a version of Cleartype which we call sub-pixel positioned Cleartype, and that uses both, and that is a part of the Windows presentation framework. So when you see the fonts in there, and when you see text that's rendered with Windows presentation framework, you're seeing the best that we can do so far. We'll get better too. You know, we continue to evolve, and we have some other technology ideas coming forward. But Windows presentation framework is, if you like, our state-of-the-art rendering.
Now, when you say better readability, are you doing eye track research with actual human beings who don't?
We're
live
doing
there
all kinds of
and studying
research.
them?
In fact, I should introduce Kevin Larson, who is a cognitive psychologist who's part of our group, who for the last 3 years has been running university research studies series. We've been funding research at many universities, looking at the medical aspects. So we have ophthalmologists like James Sheedy at Ohio. We're looking at, you know, kind of computer science aspects and so on. So we've been running a full research program, and I should let Kevin tell you about some of the findings that we've got and some of the people we've been working with.
It's hard to know where to start. Yeah, we do have a very large research program going on. You mentioned eye tracking, and we're working with Keith Rayner at UMass Amherst, on an eye tracking program where we have again reconfirmed that people read faster with Cleartype, and we're measuring where that performance enhancement comes from. Is it when you fixate on a particular word? Are we recognizing it faster during the fixation, or does it make it easier to recognize more information out in paraphobia? And that's still an open question for us that we're trying to understand better.
But we have some early data about performance enhancements, for example, the early stuff, the improved speed of recognition.
How much are we talking? 0.5%? Are we talking 4%? 10%? Is it something noticeable?
In word recognition accuracy, which is measured with a task called lexical decision task, which briefly is we show either a word or non-word up on screen very quickly and ask people to recognize it. People are 17% more accurate if Cleartype is turned on than with black and white rendering. Okay. And if we go into more natural tasks like sentence comprehension, where we have two people read, we have a lot of people read two sentences, and they've got to decide if those two sentences go together. We find that people read the sentences 5% faster with Cleartype, and are also 2% more accurate on making the decision of whether or not they go together. Which is interesting, getting both speed and accuracy improvement, because usually you see a speed-accuracy trade-off, that as you do things faster, you become less accurate. But with Cleartype, you get both faster and more accurate. And then if we look at longer-term reading, we've done work with Andy Dillon at Texas, who showed that when people read over 5 screens worth of text, that people read faster with Cleartype, and that there is a speed advantage on every page. So it's not just initially when you turn on Cleartype, you start reading faster, but the advantage holds true over multiple pages. And then even in non-traditional reading tasks like scanning an Excel spreadsheet, you find that if you have people perform tasks where they've got to go find a certain kind of information, that people will do that about 7% faster with Cleartype than with black and white.
Interesting.
These are big performance improvements. You know, if you cranked out a 2% speed improvement in a piece of software, you know, people would be dancing on the roofs. You know, because these things I've noticed. So a 7% increase, and this is not 17% raw increase, but a 7% increase in real world tasks. That's a lot of productivity. It represents a huge amount of money, because we have a lot of research that shows that people who sit at computers spend about half of their time reading. So if you pay somebody $100,000 a year and they spend half of their time at their system reading, and you crank a 7% improvement in there, guys like Jacob Nielsen, who's not at Microsoft, the kind of a web interface usability guru guy. I mean, he came up with a figure. What was Jacob's figure? Can you remember? It was huge. It runs into billions of dollars a year in many billions of dollars a year in improved productivity. Because reading's this core task. We do it all the time. We spend about half our time reading. If you give a 7% productivity improvement, speed improvement, and accuracy improvement, you've just generated a huge economic benefit for anybody who's using that technology.
Why is it so hard to get people to upgrade when there's such an immense benefit? I walked through a pretty sizable company the other day, and they all had 12-inch screens. And we know by our other research that if you have 2 monitors that are high resolution, you can increase your productivity by even more than what we're seeing here.
Well, in the past there have been all kinds of promises dangled in front of people about improved productivity, and it took, there's this kind of initial feeling when computers were introduced that were going to lead to increased productivity, and they didn't immediately, because it takes time for these things to get assimilated and become part of your workflow and all the rest of it. If you look at the benefits of the web, for example, the web was sitting around for quite some time. The internet was sitting around for a long time before.
I had dinner with Douglas Engelbart. In fact, he's going to be on Channel 9, and he invented the mouse 25 years before it was widely used.
Yeah, in the beginning, I can remember when Windows and windowing and the mouse and graphical user interfaces were first introduced, and very few people wanted to know, particularly in the IBM PC world. I can remember having to, when I was working at Aldous, I can remember having to go to IBM like a year into all of this stuff and actually take a mouse and a graphics card with me so I could install Windows on one of their machines. This was back in the UK. So graphical user interfaces took a long time to come off, and a lot of the productivity benefits were a long time coming. I think they're real, but they're a long time coming, and plus there have been certain stages. There was a big hype about the paperless office in the 1980s, 1990s, for example, and people said, we're going to get so much more productive. Well, it's just happening now, because we're seeing that at Microsoft we hardly use paper for internal communications. Everything's done in email, ordering systems, invoicing, all that stuff. It's all paperless now, and the web's a key part of that. Having the web kind of made a big difference, because you can pretty much take it for granted that everybody's connected. When I started an email in 1984, there weren't that many people, and it was 300 bits per second. You could watch the characters being drawn on the screen one at a time. It takes time for the technologies to mature and get to a point. But the difference now is that one of the things we wanted to do was get hard data, which was not kind of a marketing hype here. This is peer-reviewed university research that's published and thrown up there for everybody to throw rocks at, and so has to be absolutely solid. So we have a 7% hard productivity improvement proven by lots of research. These things will eventually, it also takes a long time to get corporate customers to upgrade. We see this all the time.
I see a lot of people with Windows 2000 that don't have Cleartype, capabilities.
Yeah, it takes time, because corporates make it. Normally, you find if they're going to do an upgrade of operating systems in the corporate world, they generally tend to time that along with replacement of hardware. So those cycles are like 4 or 5 years for hardware replacement. We're always kind of like about 5 years ahead at least, and maybe even further ahead for a lot of mainstream users. It takes time for these things to happen, and so upgrades are always a slow process, you know.
Yeah. What else would you guys like me to know about?
Well, one other thing we should
type?
talk about. We've talked about the new typefaces in Vista. One other project we should talk about is the Japanese, which is a whole other level of magnitude of effort. I mean, we spent almost as much money on the Japanese as we did on the other faces. In fact, we might even have spent more.
Well, that's
on
a good point, because we're very American centric in the computer industry, and we don't realize, hey, there's a few people living across the pond.
We do have kind of an advantage, although because there's a Welshwoman and an Irishman and a Scotsman, and when we walk into a bar, the bartender says, "Okay, what's the punchline?" But we also have a Swiss, Beat Stamm, who's Swiss but speaks about 8 languages, including Russian and Japanese. We have a Russian woman who's an engineer, Tanya Matskovich. We have, well, you may not know, but Greg is a Native American. He's a tribal member. We're a pretty disparate group. We don't have any Japanese or Chinese members of the team, and one day, or Indians, one day that may happen. I'd love it to happen.
Actually, what I'd like to say here is, I mean, it's arrogant to think that you could, if you're Latin-centric, you go off and you design a Japanese font or a Cyrillic font and know it all. You don't. So you work really well with experts in the field. So when we started this whole project, in fact, it was the Latin project that where we actually developed the Greek and the Cyrillic in parallel with the Latin. So usually when you're doing a font in the past, it's always been Latin-centric, and then maybe you tack on a Cyrillic or a Greek or something afterwards. But this time round, we wanted it's kind of a multilingual, holistic approach, and so we had experts for the Cyrillic and the Greek that were consultants to the designers that we had designing the Latin. And then for the Japanese, we worked with Eiichi Kono and font company called C&G in Japan, and Matthew Carter, who designed the Verdana style for Mario. And we all worked together as a kind of virtual team to actually produce this, but it wouldn't be anything like as good without their input. I mean, they're the experts, they're the wonderful designers who actually helped us do this.
Do you have a before and after sample, or?
No, but what I do have quickly is, well, one thing with the Mario font, Matthew, his friend Eiichi, they work together really well, and so our premise was that the Latin and the Japanese would align really well on screen. They'd work in a horizontal reading pattern.
One of the problems that you see in Japanese websites, for example, is in the fonts, there's lots of Latin words, English words in Japanese websites, and the English and the Japanese always go together really badly. They look awful together. The English characters are very poorly designed, and they don't homogenize with the Japanese, and the baselines are different because we're working on a baseline in Latin, but in Japanese there is no baseline as such.
Yeah.
The fonts were originally designed for vertical writing. So the game was to design a Latin and a Japanese side by side with experts from both and homogenize them.
Basically, you see it best in print and on screen, on an LCD screen, where the Japanese and the Latin combine really well.
And here we have some. You can go back there. You have some examples of Latin and
how it
Japanese.
sets, and we have some in the booklet as well. And if you have a look on the website, on any website that would showcase Japanese and Latin together, you'd be able to see it. One thing about the Japanese the forms we were looking at, the problems we have are too many horizontal bars and not enough pixels to represent.
Yeah.
And so we were talking with Eiichi, and we were drawing up on a drawing board kind of ideas of how would we represent this in stroke reduction. And so we came up with this idea of the informality of handwriting, the speed of handwriting, what features actually get dropped out.
Yeah.
And so this this is a representation of, in hinting, what happens with this particular character, taking examples from handwriting, the original handwriting. And this is the same character, and this is the original outline design, and at certain sizes you'll see it will collapse.
Yeah.
There's not enough room to actually represent it well on screen.
Yep.
And this is it hinted with the stroke reduction down at the small sizes.
Yeah, it's much, much nicer.
So, okay.
Now, in the past, that stroke reduction was done by hand tuning bitmaps. You know, as I mentioned earlier on, typefaces, Western typefaces have changed. In the beginning, there were outline typefaces, and we created, you know, the computer industry created screen faces, which were basically bitmaps. Then we moved on to the screen bitmaps being generated from the outlines using techniques like hinting. But in the world of Japanese and Chinese and Korean typefaces, that never happened. It looked like it happened. You know, you have the one typeface like Mincho in Windows or Gothic. But in fact, there's embedded bitmap data for every character at every size, say between 7 and 22 points. So for Mincho or Gothic, there's about 400,000 bitmaps embedded in the outline data. And when they're being rasterized at small sizes, the system knows the resolution of the display, how many pixels it has, and goes away and brings the bitmap instead, and does not create that bitmap from the outline. Now what that means is when somebody was creating a Japanese typeface in the past, the bitmaps are stroke reduced.
You'd have to do a lot
Right?
of work.
You have to do it by hand. A typographer with knowledge of Japanese, who knows which strokes you can take out without destroying the meaning of the character, had to do every single one of these. So creating a new Japanese typeface was a 50-man-year effort. We know because one company did it, produced a font for LCD display, a Japanese company, and they invested 50-man-years of development in it, right? So what we did when another piece of technology that we wanted to do with the Japanese was to say, can we do the same for Japanese as we did for the Latin, but can we use the hinting model, the hinting language, to do the stroke reduction as well as displaying the right pixels and so on? And that's basically what we did. So
how many man years did this one take?
Oh, a lot less.
A lot less. It took under 2 years.
Yeah.
Under 2 man years.
Yeah.
Yeah.
Women
And-
years or
Well,
Yeah.
people years. Gotta be politically correct, right?
have to clarify something though.
Yeah.
We had a regular and a bold weight, and each weight had 20,000 plus characters per weight.
So in fact, the 2-man years of investment was in 2 weights, because today Mincho and Gothic don't have a bold.
Okay.
They're kind of computer emboldened, which is awful, right? You can't, as we've proved so many times in the past, you can't algorithmically do this kind of stuff. You know, this is like the early italics that were done, where the computer just skewed the Roman by 45 degrees, and Geraldine has a deep hate that we all kind of do, but the typographers like Mike and Geraldine would kill
Well-
people.
Tell me some of the stories.
Okay, so going back to the size of the actual character set, we had to think about how much time we would take to actually hint with the stroke reduction. What would make the most bang for your buck? What would be the quickest way to do this?
Yeah.
And so we actually made 3 different kind of buckets of hinting information. Level 1 would be this manual hand hint, quite intensive hand hinting on the first, most frequently used 2,000 odd characters. And then we had a kind of second level of about 5,000 characters, and then the rest were more auto-hinted, auto-generated, and that's the way we actually tackled that. And coming down to the italic, ideally I'd like to see a true italic. If you have to italicize, it would be great to have a true italic made.
Cool.
Geraldine actually drew the italic characters for the Palatino linotype, and they're gorgeous. It's a beautiful italic.
Once again, Palatino linotype had the outlines,
Yeah.
but they had about 860 or so outlines, and we had to make the character set up to 1,329. We were making a large open type character set, and yes, I did draw the remainder, and we sent our drawings off to Herman Saff, and so did my colleagues Michael Duggan, Sue Lightfoot and Ian Patterson from Monotype. They drew their weights as well. There were 4 of us, and we all sent our drawings off to Herman and had our drawings come back with little, little corrections, and some they're all in German, and some were just little things, and some things were no. So yeah, it was great. It was really good.
999.
It was
kein Deutsch.
it was a very good project to do with linotype. It was great.
Well, thank you very much. I'm almost out of tape, so we better.
On the Mierio, we took the same approach. We went out to world experts. We got the best outlines we could get. We looked at the Cleartype technology. We innovated using the Cleartype hinting model to do the stroke reduction as well. And again, Mierio will ship in Windows Vista and Office. No, in Windows Vista.
Well, you guys have done a great job. Thanks for spending an hour.
It's great to be working at a place where you get the opportunity to do projects like this. There are very few places in the world where you can bring together, the kind of experts that we've assembled in this team, the installed base where you can make that kind of impact, and also the installed base that allows you to do projects of this kind of scale. It's not everybody who can do it, because you do have to spend a fair amount of money, and you have to spend a fair amount of time. And one of the great things is that Microsoft's prepared to do these things. Yeah, I mean, I'll circle back to Bill.
I have 20 seconds.
Right? I'll circle back to Bill. We showed these fonts to Bill at the end of the day, and his reaction was, "Wow, these things are incredible. I didn't think you could do it for the money that you were spending."
Well, thanks a lot, guys.
Thanks.
Thank you. This was great stuff, and I'm looking forward to seeing this type on my computer soon. So. Cool.